In this video, I'm going to talk about blood filtration, and specifically I'm going to talk a lot about the nephron. But before I can start with that, I want to first give a slight overview of the kidney, the organ in charge of blood filtration. So here's a really rough diagram, and in blue I've drawn this thing that is a nephron and then a collecting duct, the straight part. And so the nephron, it makes the filtrate the urine, and the collecting duct brings it to this yellow structure. This yellow structure is the renal pelvis, and the urine that goes here will go down through this tube called the ureter to your bladder and then out of the body. But this outer pink part, this is also the renal cortex, and this inner pink part is the renal medulla, and this distinction is going to be important for our discussion of the nephron. So here is a really rough drawing of a nephron, and in this dotted line here, that's the border between the cortex, so the cortex is up here, and the medulla down here. So let's start with the beginning of the filtration process, which is this blood. So blood is brought to the nephron by the afferent arteriole. And what happens is it enters this ball of capillaries, this little tuft called the glomerulus. And here, the pressure of the blood is enough so that some of the fluid actually leaks out and is collected by this yellow cup. Now, the type of fluid that leaks is basically plasma without plasma proteins and blood cells. So no proteins or blood cells. But that does leave us with a lot. We have our glucose and other nutrients. We'll have salts, we'll have urea and other waste, etc. So that all comes out and it gets collected by this cup, and this cup is called Bowman's capsule. And then the rest of the blood, because only about 1/5 of the fluid comes out, it's taken away by this red arteriole, which is the efferent arteriole. So what exactly happens to the filtrate, the stuff that leaked into Bowman's capsule? Well, what happens next is it goes into this little curvy part, which is the proximal convoluted tubule. So we have actually the majority of the reabsorption happening here. So everything important, like the glucose, the amino acids, the vitamins, those are all going to be actively reabsorbed. So active reabsorption is key nutrients. We're going to actively reabsorb sodium chloride, and we're also going to passively absorb stuff. So we're going to passively reabsorb bicarbonate. We'll passively reabsorb some potassium, and because we're reabsorbing all these solutes, some water is also going to be reabsorbed through osmosis. And finally, we also can actively secrete protons into the filtrate. So again, the bulk of reabsorption happens in this beginning curved part, the proximal convoluted tubule, but there is still some more work to be done. And that happens in the loop of Henle. So the loop of Henle is this little hairpin shape here, and it's the only thing that actually dips into the medulla. And the one thing I want to say about the medulla is that it has high osmolarity. It's really concentrated down deep in the medulla. And so here's our loop of Henle here. I'll write it out, loop of Henle, and it has the descending limb and the ascending limb. Now, the descending limb is permeable to water. So water can passively diffuse out of the filtrate because in the medulla it's so concentrated in the interstitial fluid. Now, we are impermeable here to sodium chloride. So NaCl, that's going to be stuck in here. So as we move down, our filtrate is losing water and keeping out salt, so it's becoming more concentrated. Now the properties change when we enter the ascending limb. So the ascending limb is actually, we have some passive reabsorption of salt, and then later we have active reabsorption of salt, and sodium chloride is what I mean. And we actually cannot have any reabsorption of water. Now, this is really important in that, one, we're reabsorbing some salt, but also this is what actually maintains the high osmolarity of the medulla. So this is a really important process. And as we go up, because we're actively reabsorbing all this salt, our filtrate becomes more and more dilute. So draw that and say dilute. And that brings us to this second curvy part. And over here, let me just make some space. We have the distal convoluted tubule. So here, this is where we reabsorb. So let me just make some space to write. So this is where we actively reabsorb some salts. So that would be, we'll reabsorb some more sodium chloride, and then we might reabsorb some bicarbonate, and we might actively secrete some protons or potassium ions. And the thing that really determines what we're doing in the distal convoluted tubule is hormone signals. So depending on what we need to maintain homeostasis, the distal convoluted tubule will do some of this reabsorption or secretion. So that brings us to this long stick thing, and this is the collecting duct. This is not technically part of the nephron, but it's what brings the filtrate to the renal pelvis, where it can be stored and then later gotten rid of. So as we move through the collecting duct, we can either lose water. If the collecting duct is permeable to water, we can reabsorb some sodium chloride, and down here, oftentimes we'll lose some urea, and this also is deep in the medulla, and that contributes to the osmolarity of the medulla. Now, as far as the water and the salt, this is also hormone dependent. So it depends on how much water and salt we want to conserve. That is a good overview of a nephron and how filtration happens, and I hope that's been helpful.